My name is Marquita Moreland, and I'm going to be presenting to you a project that I worked on last summer at the University of Rhode Island, entitled Identifying Remnants of Evidence in the Cloud. I worked on it as a National Science Foundation Research Experience for Undergraduate intern at the University of Rhode Island, and the project is supported by the U.S. Department of Justice's National Institute of Justice in a grant to the University of Rhode Island. In my talk today, I'm going to go over first the background of what cloud computing is, and then go into the problems it poses to law enforcement investigators when the evidence they're searching for is actually in the cloud. I'll then go over the solution we've come up with that involves identifying remnants of cloud computing that are left on the devices that law enforcement has been taught to seize. I will show you the procedure that we go through in identifying the remnants, show you some of our results to date, and then discuss our future work in this project. So what is cloud computing? Cloud computing is the idea that storage of data and applications that used to be on physical devices, like computers, pads, phones, is more and more moving into the cloud, where the service and the storage is provided by a server and users use an internet connection to access the applications and the storage that they wish. There are different forms of cloud-based computing. Applications include things like Google Docs or now Google Drive, where in a Google Docs application suite you're getting all of the word processing, spreadsheets, and typical Office applications offered as a service by Google and being executed remotely instead of the application being on your device and executing on your device. Other applications like photo processing and Photoshop can now be done online. Video editing can be done online as a cloud application. Another class of cloud computing is the idea of storage, where documents, files, can be stored in a cloud application and accessible to multiple devices. iCloud by Apple Computing is an example of this, where it stores backups of your applications, your songs, your data in the cloud, making them accessible to any Apple device. Dropbox and Windows Live Mesh are like having a remote hard drive or drive that looks like storage on your computer, but anything that's actually stored on that is stored up in the cloud, removing it from your actual device. Other uses of the cloud is to provide infrastructure like virtual machines to do computing on your behalf. The International Data Corporation, IDC, estimates that cloud revenue will generate over $56 billion in 2012 and that it's only going to be growing. This means more and more people, more and more businesses are moving into cloud computing, and as they do so, more and more evidence and investigations will be found in the cloud. As more and more evidence moves into the cloud, it's posing a problem for law enforcement. Law enforcement is traditionally taught how to seize devices and use tools like EnCase and FTK to search the device for the evidence that they're looking for. But it's becoming more and more the case that there would be very little evidence on seized devices when cloud computing is used. The evidence, the data, the applications that operated on it, are all in the cloud, not on the device that law enforcement has seized. The actual physical evidence that they're looking for is probably located in a huge data center with data way too vast for law enforcement to go in and say, copy all of the data in an imaging process that they're taught in a forensics procedure. There's just too much data in a data center for Amazon or Google. Often the cloud applications store evidence in a proprietary format. So it's not in a format that's recognizable by most forensic tools. It's in the format that makes it most efficient for the cloud providers to store it. The actual physical data may be in data centers that are not concentrically located in one location. They may be located in multiple locations across the world, making it impractical for local law enforcement, for instance, to actually go out and physically obtain the data the way they've been taught. To complicate it even further, the physical data may be located in different jurisdictions with different laws on how to actually access the data. So what this means is that physically obtaining the data, like law enforcement has been trained to do by doing a search warrant and doing an imaging process, simply doesn't work with cloud-based computing. Another interesting problem is that Since the cloud is accessible from multiple devices, simply seizing a suspect's device doesn't prevent the suspect from accessing the data and possibly destroying it, which makes it important for law enforcement to identify quickly that cloud applications have been used and issue preservation orders to the providers. All of these are new problems facing law enforcement with the advent of cloud computing. The solution that we pose here is that law enforcement is able to seize devices, and fortunately, there are remnants left on devices indicating that cloud computing can be used. And the devices these days are coming down to a certain class of devices. So the operating systems most in use are Windows, versions of Mac OS, and possibly Linux. And on phones that might have remnants of cloud computing, they're pretty much versions of Android or iOS. So there's some convergence in operating systems. So the solution is that law enforcement needs to be able to seize a device and go through the operating system of the device, finding remnants that indicate that cloud computing has been used. And in particular, they need to find enough remnants to be able to form a warrant to the keeper of records of the service provider. Most major cloud providers, such as Amazon and Google, respond readily to warrants to law enforcement as long as the warrants are narrow enough in scope and well formed. To do that, law enforcement needs things like what cloud application was used, what document and file names they're looking for, the username of the suspect in terms of the username on the cloud provider, and the dates that documents were created, modified, and accessed. All of these narrow the scope of the warrant so that then the cloud provider like a Google or an Amazon can go and retrieve the documents under warrant and provide them to law enforcement, saving law enforcement having to actually go and face the essentially prohibitive task of going through and finding the evidence themselves. A well-formed warrant will have the cloud provider deliver the evidence to them. Some of the typical remnants that are left on devices. Cached websites. Cached websites can be a rich source of information for cloud-based applications that use a browser. Similarly, history and cookies can indicate browser activity that could also indicate cloud activity. Some cloud applications, have an installed component, such as Dropbox typically has an installed component, which means that it leaves files on the device and or registry entries or some kind of entry on the apps or software catalog on the device. These kind of things are the remnants that law enforcement needs to indicate that there was cloud computing and to form a well-formed, narrow enough warrant for the cloud provider to respond. We've used several techniques in our research that we're presenting here to identify the cloud remnants. The first technique we have up here is using hash sets. Hash sets are basically taking hash values like MD5 hashes or SHA-1 hashes of files and creating a set of these hashes indicating a representation of a set of files. By creating the hash sets on a device, an operating system, before cloud use, and then doing a hash set after cloud use of all the files on the device, and using a tool that's used to working with hash sets, such as even FTK's forensic tool can be used, and that's what we typically have used in our lab, because it can differentiate between one hash set and a second hash set and call out the files that change based on the differences in the hash set. So we've used FTK to identify hash sets before a cloud application and after a cloud application to indicate what files were modified by the installation and or the use of the cloud application. The second technique we have up here is to use monitoring tools. Process Monitor from Microsoft sysinternals is a good monitoring tool for active applications. So as Dropbox or Google Drive or something that has an installed component interacts with other components on the web, it's an active process, and we can use Process Monitor to detect what ports it's using, what kind of protocol it's using. So Process Monitor is useful for identifying what kind of interaction goes on actively. Tools like InControl 5 are good at taking full snapshots of the system, kind of similar to what we said with the hash sets. They can identify what registry entries and files are modified in the installation of a cloud application that has an installed component. The final technique you see up here is parsing known files, files such as index.dat or SQLite databases, where it's known that cloud applications put entries in a certain format. So if we know the format from that SQLite stores the Dropbox username, or that an index.dat file stores a URL indicative of a Google Docs username, we can parse index.dat SQLite files for keywords or strings that are indicative of the remnants we're looking for from the cloud. We use all three of these techniques in our lab to come up with what the cloud remnants are that are left behind by the cloud applications we're trying to characterize for law enforcement to be able to recognize. So I'm going to present some example results. Now, we've done several cloud applications as a proof of concept so far, and I'm only going to present a couple of the results. I chose one from one category, which is browser-based applications, where the browser is used to access the cloud app. And the second thing I'll show you is a installed component-based application, where it's not just the browser, but also an installed component. For browser-based applications, we chose, to illustrate the remnants we found, we chose Google Drive, which is also embodies Google Docs. So when Google Docs or Google Drive is used, certain known or canonical URLs appear. The start page for Google Docs is typically found in an index.dat or a history or a cached website container. To list the files in Google Docs, a URL is used that looks like this. Creating a file in Google Docs has a URL that looks like this. If it's a new document, the new document looks like this and has a known document identifier, which can be useful in the warrant that's served to Google to try and get a document back. And saving, similarly with a new name, also provides a URL. By identifying the form of these URLs that are typically used, or remnants that are left behind when Google Docs and Google Drive is used, by identifying the form of these URLs, we can create parsers in a software tool to look for these URLs in known locations, such as on a Windows machine in index.dat, cached websites, and history files. The second example that I will present today is an example of a cloud application that has an installed component, and we're using the popular Dropbox application. Dropbox, when it's installed, has two key files that have the remnants that are very useful to law enforcement in terms of evidence. It has a file called config.db and a file called filecache.db. Our work with Dropbox shows that the config.db can be parsed to find various things that can be helpful in a warrant, such as the version of Dropbox being used, the Dropbox host ID, which is a 128-bit key, and it pertains directly to the user account. So that kind of information in a warrant to Dropbox is usually sufficient for them to determine the user of interest. The path can be determined from the config.db, which is the file name and the path to it that can be used. The Dropbox username can be directly pulled out of a different part, and a list of recently changed within a certain time period files can also be found. The filecache.db file has things like what path on the server that the file is actually located in, the local file name on the server, the hash file using a SHA-256 hash, the local size of the file, the modified time, and the created time. All very useful in narrowing down the scope of the warrant when law enforcement is asking for information that a suspect might have on their Dropbox account. So that provides two examples of remnants that we've worked in our lab to characterize for law enforcement. We've done others. For instance, we've done Windows Live Mesh and others. Primarily, we focused our initial work on the Windows platform and the Internet Explorer browser. But we are working on other browsers. We're working on characterizing how Chrome stores things, how Safari and Firefox stores them. Because each browser stores remnants in a different way. So all of these have to be put in so that if the browser is present on the seized device, that the tool that we are creating for law enforcement can know by browser what remnants to look for. We've written a prototype tool. The work that is done at the University of Rhode Island, typically the product that URI turns over to the Department of Justice is a working tool that law enforcement can use. So we have a prototype tool that's made to be easy to use for law enforcement so that they run the tool and it presents a report laid out with what kind of cloud applications were used and just the remnants that are important for forming a warrant, with drill down capabilities to get more details if they're really interested. But the idea is to keep it kind of high level so that they can quickly determine what kind of information they would need for a warrant from the remnants that are left on the devices they've seized. As I mentioned, the preliminary work has been done on Windows computers, but their similar work can and will be done on other browsers, other operating systems, and other devices, phones, and the applications that they use. For instance, like Google Docs and Google Drive is available as an app for a phone, and so it's going to have its own form of remnants when it's present on a phone. And again, as we said, the end result here is to release it as a tool to law enforcement, such as the University of Rhode Island has done on other Department of Justice projects, such as their child pornography scanner and their steganography detection tools. The prototype will be released free to law enforcement. Feedback will come back from law enforcement. Another important aspect of the tool is that it's going to be released so that as law enforcement and others in the community gather other characterizations of other cloud applications, the tool is designed to have the new characterizations easily plugged into the tool so that the capability of the tool can continue to grow as cloud applications change. The website I have up here is for the University of Rhode Island's Digital Forensics and Cybersecurity Center, where they list all of their research projects, including this cloud-based application. And we have an email address up there for one of the primary researchers working on this project who can answer your questions. Thank you for your time, and I'll take questions now.